Hello, welcome to the first tutorial video on integrating exponential functions. Okay, so in this video I'll show you how to integrate exponential functions. Okay, alright, so if this is your first time of watching a video on my channel, kindly subscribe to my channel for more videos. If you're a fan of my channel and if you're not subscribed yet, kindly do so for more videos in the future. Okay, so let's start. Now if I have an exponential function like this, integral of a to the x dx, how do I integrate this? Okay, first of all, we make use of a basic definition in integration of the general exponential function e. Okay, so let me write that. If I have integral of e to the power u of x, alright, what this means is that the power there is a function of x, then the whole of this is equal to 1 over the u of x. Okay, sorry, I'm coming. The whole of this will give us 1 over u prime of x. Okay, where u prime of x means what? The differential of u. Okay, then e to the power what's the same u of x. Okay, then plus c. So kindly keep this. Alright, keep this, that whenever you have e to the power u of x dx, whenever you are integrating such thing, it will give you 1 over the differential of the power of the e times the same e to the power u of x. So this is the basic definition we'll use for integrating every exponential function. Okay, alright, now with this, let's also learn something. Okay, with this question over here, integral of a to the x dx, this side, you can't do anything to it. What you can do is try to manipulate it so that you can get something in terms of what e to the power something. Okay, but in mathematics we have something that we call creating and destroying. Okay, so basically when it comes to some of the integrals, you can't just do them straight away like that. So what you do is you're trying to create something and you destroy it. Okay, so let's see how you're going to create this. Remember from logarithm, okay, from log, if you have a to the log of, let's say, x base a is the same as this x. Okay, so in other words, it's like you've not done anything to the function x or something like this. Let me clean here so that you see it clearly. Okay, so let's say if I have x, then this x is the same as a to the log x base a, right? All of this is cool because you can see this x here is the same here. If I have 2 is the same as, let's say, 5 to the log of 2 base 5. So far as the base here and this base here are the same, this is true for logarithms. Okay, now how are we going to use this logarithm to create and destroy something? Okay, so let's see from this question, if I want to transform this question to the power of e, okay, then I would say one thing that I should remember: the natural logarithm ln, we know that it is of base e, right? So if I say e to the ln of e to the power x, what is this? This is the same as e to the ln is what? Logarithm of whatever that you are talking about, base e. So this whole thing can give me e to the x. So it means that this function that we are integrating in this integral sign is the same as e to the ln, or this one, okay, e to the ln of it. Alright, so let's quickly clean some things. Okay, alright, so we said we can represent the whole of this by e to the ln of a to the x. This is the same as the a to the x. Okay, the reason why we are transforming the exponential function to e is because of this definition. Okay, alright, then it means the integral of a to the x dx is actually equal to integral of e to the ln of a to the x dx. Now with this, we know how to do the integral of e to the power something u of x. Okay, so what this will give us is that the whole of this integral will be equal to 1 over the differential, okay, d dx of the power ln a to the x, okay, times the same e to the power ln of a to the x. Okay, and if you can remember, we said e to the power ln of a to the x is what? The same a to the x back. Okay, then over the differential of ln a to the x ln of a to the x, okay, then all plus c. Alright, so this whole function has integral has turned to this. Okay, so the only problem that we have to solve now is the differential of ln of a to the x. Okay, and I hope by now you can do that. Alright, so let's try that and see. Let's try that and see. Okay, I have to clean some part. Okay, alright, so we said that this is the same as a to the x. Okay, and from the definition of integrating u, this is the same as a to the power x. Okay, and from this definition that we've learned here, we said that if you integrate e to the power ln of ax or ln of e to the power u of x, then it's the same as e to the power u of x, okay, here, this side, then multiplying it 1 over the differential of the power. Okay, that is what we've written here. Okay, we got e to the power u of x is the same as e to the power ln of ax, and that is what? A to the power x, from the basic definition in logarithm. Okay, alright, so with this, what we are coming to do is find the differential of a to the power ln of a to the power x. Okay, and this is equal to the same as differentiating. Now ln of this is what in logarithm form, so we just x ln a. Okay, and now ln a is just a constant. Okay, so what we are doing is just the differential of x times some constants. Okay, and differential of, let's say this is the same as differentiating 2x. Okay, and that will give me 2. Alright, or differentiating 3x. Here the only difference is that the 2x or the 3x has now turned into what? X and x. Sorry, the 2 that we see here, mostly the constant that we see here, has turned to what? A ln of a. Okay, so let's clean that and continue with it. Alright, so this will be equal to just differentiating x, and we'll get 1 times ln a, so we get ln a. Okay, so now our main question, that is the main problem that we are solving, I'm coming to clean here and write the final answer here. Okay, alright, so what this means is that 1 over the a to the x over what's the differential of the power, and that will give us what? Ln of a. Wow, very simple like that. Okay, so if everything that we said here, we just differentiated correctly, everything was okay, then this is how we're supposed to get, okay, how we're supposed to solve it. Now this means that the integral of a to the x dx is actually equal to a to the x over ln a, right, plus c. Okay, so keep this in mind. I hope you understood how we went about integrating it. Okay, alright, so let's move on to the next question so that you understand more. Alright, so this is the second question we're about to solve. Okay, and we said that to integrate exponential function, you use this idea that the integral of u to the x, u of x. Let me clean it. You said that the integral of e to the u of x dx is actually equal to the same e to the u of x, okay, over u prime of x plus c. Okay, so this is how you go about it. All right, so now we said that if what if the base is not e, what do? Then we said you use the idea that e to the power ln of whatever function you'll be given. Okay, let's say e to the power ln of, let's say q is the same as q. So now if I want to transform this 3 to the 2x into e, I know how to go about it. Okay, so now this 3 to the 2x is the same as, let me write well. Okay, alright, so 3 to the power 2x is the same as e to the power ln of 3 to the 2x. Okay, I hope this is cool, right? So if we can continue from logarithm, this can give us you let me stop here, because I don't want a situation whereby things will get messed up. Okay, alright, so now to integrate 3 to the 2 is the same as integrating e to the ln of 3 to the power 2x, okay, dx. This is very simple, right? Okay, so what you do is you're trying to make this idea, right? So this whole integral will be the same as e to the power the ln of 3 to x, okay, over then d dx, okay, of ln of 3 to the 2x, okay, alright, plus c. Okay, so this is how we'll get our answer, right? But now let's consider something. If we are to simplify the logarithm aspects of it, then it means the ln of the down here, okay, the ln of 3 to the 2x can you can manipulate it and get 2x times ln 3. Okay, so let's do that quickly. Okay, so this is how it's supposed to be 2x then ln of 3, okay, because ln of 3 to the 2x from logarithm, you know how to compute that. Okay, alright, then let's do this. And now this will be equal to e to the ln of 3 to the 2x is the same as this side, okay, and we're saying it's equal to 3 to the 2x, okay, then over, now if I differentiate this side with respect to x, now ln 3 is a constant, so I have to differentiate 2x and 2x. If I differentiate, I'll get what? 2. So I get 2 ln of 3 then plus c, all of these plus c. Okay, so let's come and write it at the top here so that we can see clearly. Alright, so this is what we will get for our final answer. Okay, so you can actually generate as a function or a formula for integrating this. Okay, but that depends on you. Me, I always prefer using this basic idea, because sometimes they will give you whereby the base that you'll be dealing with is not a number. Okay, but as far as it is a number, you can use this idea that if I have integral of a to the u of x, okay, dx, then this is the same as the a to the u of x over u prime of x ln a, okay, plus c. So this should hold only when your a is a constant, like a number, okay, or any variable different from your independent variable, that is what you are integrating with respect to. Okay, so if here is, let's say if this a is x, then we'll find ourselves in trouble from here. Okay, and we have to just go back and use this. So if this side, if this basic definition that I showed you, if this side can solve every question, then why don't we stick to that? Okay, but sometimes it will be tedious when it comes to learning those steps. Okay, so what I'll always urge you is just try this more and get more experience in it. Alright, so thank you for watching this video. Kindly subscribe to my channel if you haven't subscribed yet, and see you in our next video.